So now I'm going to show you how I was able to convert distance versus time into both velocity versus time and acceleration versus time. So what I did first was I analyzed the given graph for distance versus time wherein you could see that from point A to point B, the lines that I've drawn implies an increased movement, and then from B to C, it eventually decreases as it goes up, and then from point C to point D, as it goes down, it increases, but we need to consider the direction, which is downwards, and then from point D to point E, it eventually decreases. And then from there, I identified the face of the curve, wherein from point A to point B, it points upwards, and then for both B, C, and D, it points downwards, and then for D to E, it points upwards, the same as from point A to point B. And then I proceeded to the conversion of velocity versus time, wherein I plotted point A on the far bottom left of the graph, and then I draw a an upward line to get to point B, and then it went down to point C because, as what I've mentioned earlier, the movement decreases, and then from point C to point D, even though the movement increases, I considered its direction, which is downwards. So then I draw a line, and then for D to E, it decreases, but the movement is upwards. So I then draw an upward line to get to point E. As a result, this is the graph. So for the last conversion of the distance versus time graph into acceleration versus time graph. So I based it on the face of the curve, whether it is an upward curve or downward curve. If it is an upward curve, like point A to point B and then point D to point E, it has a positive axle. And if it has a downward curve, like point B to point C and then point C to point B, then it has negative axle, in which we could see based from the graph, from the previous graph, it has a downward curve, like I've mentioned earlier. And then, from point A, it went down to point B, and then it has a constant downward curve until point D, and then it only went up to point E because it now has an upward curve. So for the second and last item that I will be explaining, we were given this illustration of an object or a ball suspended that has tension on both sides. And to further understand this illustration, I decided to go and put it in a Cartesian plane. And then from there, I included all the necessary forces, or the force, which is the gravitational force here, which pulls it downwards. And then the T1x and the T2x. Then in a right angle, you are given 90 degrees, right? And for the illustration that we were given, it was only 30 degrees on this side. So obviously, I just subtract it from 90, which gives me 60, and then I did the same on the other side, which gives me 75 degrees. And then from there, I proceeded to the solution to find tension 1 and then tension 2. And then for the solution, I first did was to find the net force of the x-axis and to identify the forces present on the x-axis, which are T1x and then T2x. I placed a negative sign on T1x because it is located on the left side. I then transposed negative T1x to the other side, so it now becomes T2x is equals to T1x, and then I incorporated the angles, and then used cosine as the trigonometric function for T2 and T1. So I wrote T2 cosine 30 because it is the angle for T2, and then 15 T1 cosine 15 for T1 because it is the angle for T1. To isolate T2, I then divided both sides by cosine 30. And then I divided T1 cosine 15 over cosine 30, which now leads me to T2 is equals to T1 times 1.12. I cannot solve this without having the value for T1. So then I proceeded to finding the forces present on the y-axis. So the forces that are present on the y-axis are T1y plus T2y plus negative Fg is equals to 0. So I transposed negative Fg to the other side. So it now becomes T1y plus T2y is equals to Fg. And then I did what I've done earlier, which is to incorporate the angles and to use sine as the trigonometric function, which now leads us to T1 sine 15 degrees plus T1 1.12. I plugged in the value that I've got for T2 a while ago, times sine 30 is equals to Fg. So then T1 0.26. 0.26 is the equivalent of sine 15 when you input it into a scientific calculator, plus T1 1.12 times 0.5, which is equal to sine 30, is equals to 68.6 newtons. The reason why I've got 68.6 newtons is because Fg is also mg, which is mass times gravity. And in this case, we are given 7 kilograms, and then I used it and then multiplied it to 9.8 meter per second squared. So moving on, T1 0.26 plus I multiplied both 1.12 and 0.5, so I got T1. So to isolate T1, I divided both sides by 0.82 and then divided 68.6 and 0.82, which now gives me the value for my T1, which is 83.66 Newton. And this value can now be substituted for the equation that I've had earlier, which is T2 is equals to T1 times 1.12. And then 83.66 times 1.12 is 93.70 Newton, which is the value for T2.